All right, 8th grade, today you're going to be exploring the concept of differential heating, and that explains why different materials heat up or cool down at different rates. So I want you to think about your experience at the swimming pool in the summer and why it's okay to be in the water at noon in late July versus standing barefoot on the concrete pool deck, and how those two experiences are very different from each other. Chances are the water is comfortable, but if you stand barefoot on the concrete pool deck, you're likely to burn your feet. The same is true if you've been at the beach in the afternoon. That sand gets terrifically hot, yet the ocean is somewhat pleasant, and so that is a good experience. So I have 4 samples for you today. I have a container. It's full of air. I have a container that has a little bit more than 100 milliliters of water. I have a container of sand or dirt from my neighborhood. And then I have a container of black potting soil. And so all of these materials have different properties. They have different densities. So their particles are closer together or farther apart. And you can kind of explore a little bit why that is going to influence the rate at which they heat up. So here's about what's going to happen. I'm going to take these outside. I'm going to set them in the sun, and I will record an initial temperature at time 0, and then in 2-minute intervals, I will record the temperature of these materials for approximately the next half hour, 35 minutes or so. Right now, they've been sitting in my garage for a while. Their temperature is relatively uniform, somewhere in the neighborhood of 15 degrees Celsius. It's a little bit varied just because our thermometers aren't the best, and so we got some different readings. But if you ultimately want to if you find the temperature change, so final, where we end up minus the initial temperature at time equals 0, that might give you some idea about how these materials change temperature. If we wanted to reverse this, we could do it in the wintertime. We could put them in the oven at whatever temperature we wanted, and then take them outside where it's cold, or you could put them in the freezer and record the temperature as well. So this experiment works both to heat something up and cool something down to explore the idea of differential heating. Here we are in the backyard, and let me show you the setup that we have going on here. Hopefully that's showing up in the phone. You can see that I've got hopefully 4 containers. They're sitting in a quarter bait sheet pan on top of my kayak, and they're going to be here for about the next little while. Initially, when we started, I brought them into the house for a moment, and so the time 0 temperature is not all uniform because they heated up at a little bit different rates. So our data will be okay, but in general, just remember that when they were in the garage, they all started at about 15 degrees Celsius. So I'll be out here for the next little bit, trying to keep that guy from causing trouble, and we'll catch you later. Here we are, we're past 18 minutes in. The dark potting soil has a temperature of about 58 degrees. The sand has a temperature of 56 degrees. The water has a temperature of 31 degrees. And the air temperature in the empty container is about 51 degrees. Again, these are all in degrees Celsius. So you can see on the data table that I've attached here, I've recorded and read off the temperatures for the 18-minute mark, just to give you an idea of where we were. They started somewhere close to 20, have a range between 15 degrees for the water. The air temperature was a high of 26, so there's been a pretty significant change. Both the soil and the sand were at 20 and 21 respectively. Welcome back. We've crossed the 28-minute mark, but on your data sheet, I want you to recognize that at 24 minutes, I chose to highlight the values in that row simply because while it's been incredibly sunny for the majority of this exercise, we started to experience some significant cloud cover. The breezes picked up a little bit, and so at the 24-minute mark, you'll notice a significant drop in temperature for all except the water, and then it looks like that trend is going to continue for the duration of this exercise. So just note that's what's going on weather-wise, is that cloud cover's picked up, and maybe in your response you can use that to help guide some of your reasonings. Well, that's over. We're back inside. I collected data for 34 minutes of this experiment. Your task now is to graph it. You also need to complete some analysis questions about it a little bit there. Just know that this is the most information that's ever been collected in this exercise, in part because giving 34 minutes of time to sit around outside and collect data may not be the best use of class time, and sometimes science is slow, and so being able to collect good information is critical. Oh, there's another 2 minutes. But yeah, so take a look at your graphs. Let's see what's going on. Thanks, guys.